For question 9, A. 2 points X and Y 7 meters apart are on the same horizontal ground. The angles of elevation of a point P from X and Y are 50 degrees and 70 degrees respectively. Q is a point on XY produced such that angle YQP is equal to 90 degrees. I. Illustrate the information in a diagram. II. Calculate, correct to 2 decimal places, the length of XP, that is the alpha, and then the beta YQ. So for the 9A, we'll try going through the solution for this particular question. Now, if you analyze the question, it says 2 points X and Y 7 meters apart are on the same horizontal ground. So let's assume that this is our horizontal ground, and we have our X somewhere here. And let's assume that we have our Y also here. Now let's go back to the question. It says that the angles of elevation of a point P from X and Y are 50 degrees and 70 degrees respectively. Q is a point on XY produced such that angle YQP is equal to 90 degrees. I'm interested in this particular statement. Q is a point on XY produced such that angle YQP is equal to 90 degrees. If you look at this statement, it's trying to tell you that Q, the point Q, it's on the right side of Y, and Q also is on the same horizontal ground that the XY is on, because the question said angle YQP is equal to 90 degrees. So in this case, it means that definitely Q is somewhere here. Q is somewhere here, which you don't know, but it's supposed to be on the right side of the Y. So in this case, we are going to assume that once again, our Q is somewhere here. If our Q is somewhere here, then the angle at Q is 90 degrees because it was given. So in that case, it means that the angle here is 90 degrees. If the angle at Q is 90 degrees, then this is supposed to be, or there's supposed to be a vertical line here. So we are going to assume our vertical line here. In that case, it means that this point is going to be P, because it says angle YQP is equal to 90 degrees. So we assume that this is our P. Now let's go back to the question again. The angles of elevation of a point P from X and Y are 50 degrees and 70 degrees respectively. This implies that the angles of elevation of a point P from X is 50 degrees. So when we come to this point, the angle of elevation of a point P from X is 50 degrees. So this is our X, and we have our P also here. So if you stand at X and you are looking at P, it means that the angle it makes with respect to this line XY is at 50 degrees. So we draw our line. This is not drawn to scale. So the angle here is going to be the 50 degrees. And once again, if you read on, it says the angles of elevation of a point P from X and Y. So in this case, the angles of, or the angle of elevation of a point P from Y is also 70 degrees. So if you stand at Y and you look at P, the angle that is being formed there is the 70 degrees. So we draw our line from P to the Y. Once again, this is not drawn to scale. Okay, so we have the angle here to be 70 degrees. So this is the I, that is the diagram that can be extracted from the statement above. If we are to move to the II, the question wants us to find the length of XP. So it means the distance from this point up to this point. The question wants us to find the distance or the length from X to P. Now before we do that, let's try and find some angles in the triangle that we are having there. Let's consider triangle XYP. Yes, triangle XYP, that is XYP. The angle at Y, we can see that this angle here, we know that angle on a straight line at a point sum up to 180 degrees. If that is the case, then we can try finding the angle at this point. So angle X, Y, P plus angle P, Y, Q. This is supposed to give us 180 degrees. So our angle X, YP plus angle PYQ. This is PYQ, this angle here, and that is the 70 degrees. So we have the 70 degrees being equal to 180 degrees. Therefore, our angle XYP is going to be 180 minus 70 degrees, and this is going to give us 110 degrees. Therefore, it means that the angle here is going to be 110 degrees. Okay. Now once again, we can find the angle here, and it's a must, we have to. If we consider triangle XYP, we know that the angle at X here is 50 degrees. The angle at Y is 110 degrees. So we need the angle here as well. Now the angle here, when we know that when we sum all the angles, or the interior angles of a triangle, sum up to 180 degrees. So we're considering triangle XYP. We know this side is 50 degrees plus 110 degrees plus what we are having here is supposed to give us 180 degrees. So in that case, let's write that algebraically. So we are going to have angle x y p plus angle p x y plus angle x p y. Now this is supposed to give us 180 degrees. Angle xyp, xyp, this angle is the 110, that is angle xyp. So we have our 110 degrees, we have our plus angle pxy, so pxy is the 50 degrees that we are having here, this 50 degrees. So that one too, we are going to have our 50 degrees plus what we want to find, that is angle xpy, that is xpy. So the angle here is what we want to find, angle xpy. So we maintain that xpy, and they're supposed to give us 180. So let's try and make angle xpy the subject. So our angle xpy, and they're supposed to give us 180 minus, when we sum the 110 and then the 50, that will give us 160. So minus 160. Okay. And that is going to give us 20 degrees. So it means that the angle at this point is 20 degrees. Okay, let's redraw just the triangle XYP. So let's assume that this is triangle XYP. It was derived from this particular triangle. So we have our XYP, and that is what we are having here. And we know that now this side was 50 degrees. This side was 110 degrees. And this side is 20 degrees. And we know the distance, the length from X to Y to be equal to 7 meters. Now the question wants us to find the distance from X to P, this distance. Okay. Now the triangle as it stands like that, it's not a right triangle. So we are going to use the sine rule here. Now for the sine rule, in this case, it's going to be the length of side XP over sine of the angle that is opposite to the side XP. In this case, the angle that is opposite to side XP is this angle, that is 110 degrees. So sine 110 degrees. And this is supposed to be equal to, once again, we take side xy. So we have xy over the angle that is opposite to that. And if you take this as your xy, the angle that is opposite to that is this angle. And the angle is 20 degrees. So it is going to be sine 20 degrees. Therefore, the xp that we want is what we have to make the subject from this small equation. So we are going to have side, or the length of xp over sine 110 degrees being equal to xy. We know xy to be equal to 7 over sine 20 degrees. So in this case, we make xp the subject. And if we want to make xp the subject, we can do cross multiplication here. We can decide to use xp to multiply the sine 20 degrees, and then the sine 110 also multiplies the 7. Or because we want to make xp the subject, what we have to do is we can just take the denominator of this particular fraction, because the denominator is sine 110. Then we multiply through by the sine 110 just to get rid of that denominator, so we can just make xp the subject. Okay, so the choice is yours, whichever way that you want. Okay, so we are going to have side xp over the sine 110 degrees times sine 110 degrees being equal to 7 over the sine 20 degrees times the sine 110 degrees. So in this case, this sine 110 will cancel sine 110 here. And now you are going to be left with the side xp being equal to the 7 over sine 20 times sine 110 degrees. And this will give you 7 sine 110 degrees all over sine 20 degrees. Now you type this on a calculator, and the calculator is going to give you 19.2336. You're going to have some infinite decimals there, but don't forget the question was asking you to do what? Correct to 2 decimal places. 2 decimal places. So in this case, 2 decimal places, we are going to have 19.23, and this is the length of xp. You bring unit, but don't forget the unit was meters, so it is 19.23 m. Now for the I, or for the beta, we are to find yq. If we want to find yq, let's look at the diagram. The question wants us to find the distance from this point to this point, that is yq. And how do we do that? if you want to find YQ, then let's try and consider triangle XPQ. That is XPQ. So let's consider this particular triangle. Now this triangle is a right triangle, and we have two triangles in there. That is this triangle and this triangle. So let's consider the whole triangle there. Okay, so let's draw the triangle. We are going to have our triangle. So let's assume that our P is here, the vertical line. And we have our X here. We have our Q also here. So that our 90 degrees is here. This is our point P. Okay. Now don't forget that we have, okay, so we have our Y somewhere here. But I want to consider triangle XPQ. This side, we know that the angle here is 20 degrees. We know that the angle here is also 50 degrees. Okay. Now, if we want to use triangle XPQ, which we know that this side is 90 and this side is 50. But what is the angle here? This angle corresponds to what we are having here. This side is 20, but we don't know this angle. So we need to get the angle here. We need to get this angle. But don't forget that this side is also 70 degrees. If that is the case, this side is 70, this side is 90. So if you want the angle here, it means that the angle here is going to be what? 20 degrees. Therefore, the total angle at P, we have 20 degrees here, we have 20 degrees here. So we are going to get this side to be 40 degrees. Now we know the distance from X to P, and that is 19.23. So once again, we are going to consider sine rule, and we use the idea of sine rule to get the distance from X to Q, because we know that XQ is the summation of what? XY plus YQ. When we do like this, we can get the distance for YQ. That is the reason why we are finding the distance from X to Q. Okay, so using this triangle here, XQP, we want to use the sine rule. And from the sine rule, or for the sine rule, using this particular triangle, we are going to have side, or the length of XP over sine of the angle that is opposite to side XP, and in this case it's what? 90 degrees. So we are going to have sine 90 degrees, and this is equal to the side that we want to find, that is XQ. The length of XQ over sine of the angle that is opposite to that. So angle opposite to XQ is this angle, and that is 40 degrees. So it is going to be sine 40 degrees. Now in this case, we want XQ. We want to make XQ the subject. So we are going to have our sine 40 degrees multiplying the side XP over sine degrees being equal to the same sine 40 degrees times XQ over sine 40. Now this sine 40 is going to cancel this sine 40. So for this side, we are going to be left with the sine 40 degrees times the XP, which we know that now the XP is 19.23 over sine 90, which is 1. And this will be equal to the length of XQ. So in this case, we'll be having sine 40 degrees multiplying 19.23 or 23. And this will give us the length of XQ. So now we'll be having the 19.23 times sine 40 degrees, and this will be equal to the length of XQ. When you multiply the 19.23 times sine 40 degrees, your calculator should give you 12.36. Okay, being equal to the length of XQ. Now let's go back to this triangle. XQ, from what we are having here, XQ is equal to XY plus YQ. Okay. So we know that the length of XQ is equal to XY, length of XY plus length of YQ. Okay. So if the question is asking us to find the length of YQ, then it means that here we can make YQ the subject, but we can substitute the values for respective sides. XQ we had 12.36, so we have 12.36 being equal to XY, which is 7, so plus the length of YQ. So making YQ the subject, let's shift this 7 to the side. So we are going to have our 12.36 minus 7. And this will be equal to the length of YQ. Therefore, we subtract, and this will give us 5.36 being equal to the length of YQ. Therefore, the length of YQ is equal to 5.36 meters. So this is how to solve the Wassce question 9A, the COMAT paper 2. We have different approaches of going through this question, but this is one of the approaches. Now let's move to the B. The B says solve the equation 3x all over 1 minus x plus 2x all over x plus 1 is equal to 2. For this equation, the first thing you have to do is to find your LCM. So our LCM is going to be the 1 minus x and then the x plus 1. So we're finding our LCM. What you have to do is you multiply through by this LCM. So it means that when you take each term, you multiply that by the LCM. So we are going to have our LCM, which is the 1 minus x plus 1 times 3x over 1 minus x plus the same LCM, which is 1 minus x plus 1 times the 2x over x plus 1 is equal to the same LCM, which is the 1 minus x plus 1 times 2. Now 1 minus x is going to cancel 1 minus x. So you are going to be left with x plus 1 multiplying the 3x. So we'll be having 3x multiplying x plus 1. Once again, this x plus 1 is going to cancel this x plus 1. So you'll be having 1 minus x multiplying 2x. So you have your plus 2x multiplying 1 minus x. For this side, you are going to multiply all the 3 terms. So we hold on to the 2. We try simplifying the other 2 expressions. So 1 times x is going to give us x. 1 times 1 will give us 1, so plus 1. Minus x times minus x will give us minus x squared. We have minus x times 1 will give us minus x. Okay. Now let's simplify the expressions further. So let's expand any bracket there. So 3x times this is going to give us 3x squared plus 3x plus we come to this term 2x times 1 will give us 2x. 2x times minus s will give us minus 2x squared, and this will be equal to what we are having in the bracket is going to give us x will cancel this x, so we are going to have 1 minus x squared. Okay, now 3x squared minus 2x squared, they are like terms. That is this 3x squared, and then they are like terms. Therefore, when we subtract that, it's going to give us x squared. Once again, 3x and 2x are like terms, so we add them, and that is going to give us 5x. Okay, this will be equal to 2 times 1 will give us 2. 2 times minus x will give us minus 2x squared. So let's rearrange the terms. So we'll be having x squared plus 2x squared plus 5x minus 2 is equal to 0. Okay, now we simplify this further, and this gives us 3x x squared plus 5x minus 2 is equal to 0. The equation that we are having here is quadratic equation, so we need to solve this quadratic equation. We have different approaches. You can decide to use the factorization method, or the completing of squares method, or the general quadratic formula. Okay, so we want to use the factorization method. Therefore, we are going to have our 3x squared plus 6x minus x minus 2 is equal to 0. And I hope you understand why we have the 6x minus x. For the factorization method, you take the constant, and the constant in this equation is the negative 2. You take the negative 2 to multiply the coefficients of the x squared, and that is the negative 6. That will give us negative 6. You find two numbers in which when you multiply you get negative 6, but when you add you get the coefficient of x, that is 5. So that is how come we use 6 and a negative 1. Because when you multiply these two numbers, you are going to get negative 6, but when you add them, you are going to get positive 5. So we brought the first term, that is the 3x squared. In place of the 5x, we use the 6. So we have the 6 here, we bring the x, and then we have minus 1 also here, and then we bring the x. Alright, so minus, that's we bring the constant term there, and that is equal to 0. So the next thing for us to do is we take the first two terms, we factorize. So the common factor there is 3x. So we have our 3x, we open bracket, we have x plus 2, we have minus 1 x plus 2, and this is equal to 0. So this is going to give us x plus 2, we have 3x minus 1, and that is equal to 0. We try solving for x. So in this case, we take each linear factor here, then we equate it to 0. Alright, so we have x plus 2 is equal to 0. X will be equal to negative 2. Or we take 3x minus 1 is equal to 0. We have 3x is equal to 1. We divide both sides by 3. And we have x to be equal to 1 over 3. Alright, so therefore our x is equal to negative 2, or x equal to 1 over 3. So this is the end of the question 9 of the Core Maths paper 2 of the Wassce 2020.